In the next couple sections, we're going to talk about the metric system, conversions, and problem solving. So sections 2.4, 2.5, and 2.6 I'm going to combine into this one video. In the metric system, the following base units are used for mass, length, and volume. So for length, we have the meter. For volume, we have the liter. And for mass, we have the gram. We are going to talk about common small and large metric prefixes and units, and we will learn how to convert from one unit to another. So we have units that are smaller than the meter, such as the centimeter. We have units smaller than the liter, such as the milliliter. We have units larger than the gram, the kilogram, and smaller, the milligram. We're going to learn the prefixes, several prefixes, both large and small, and how they equate to the base unit. The way that I'm going to present this to you is a little bit different than your textbook table 2.5. Okay, it's a little bit different, but similar, because I want you to think in reference to the base unit. I want you to think in reference to the base unit of a meter. Units smaller than this and units larger than that. Think in units smaller and larger than the liter. Remember, I showed you the 2 water bottles together making 1 liter. And then 1 gram. I told you that roughly the mass of 1 penny is about 2.5 grams. So think of a penny split in half, roughly. That's about 1 gram. Okay, so think of these reference units, these base units, when we go into this video and we're talking about small and large units. Let's look at some of these units that are common in chemistry. Small units are smaller than the base unit of meter, liter, and gram. We're going to look at 5 small units. Okay. The book has a couple more, but we're only going to look at these 5 for Chem 110. In 1 meter, you have 10 decimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 decimeters. The prefix D is for deci. In 1 meter, you have 100 centimeters. The prefix C for centi. 1 centimeter all the way up to 100 centimeters. You can see the markings, 90, 91, so forth, all the way up to 100. 1 meter, if you broke that into 1,000 equal parts, you'd have 1,000 millimeters. The prefix lowercase m is for milli. If you look at my meter stick, you see all these little tiny black lines. They are representative of millimeters, and there are 1,000 of those. If you took this meter stick and broke it down into 1,000,000 equal units, you would have 1,000,000 micrometers. Some people like to say micrometers, okay? Micrometers, micrometers, same thing. This prefix is the Greek letter mu, and it kind of looks like a handwritten, scripted U with a little bit of a wave in front of it, okay? The Greek letter mu for micro. Now, because of potential discrepancies between micrometer and millimeter, healthcare professions usually use MC for micro. Just imagine if you had to give somebody a dosage of something in micrometers, or we should actually, when we go to mass, micrograms. Say you had to give it, a dosage had to be given in micro units, and instead it was given in milli units. You could have a person be overdosed. Okay. All right? If you gave them in milli instead of micro. So in engineering and in science, micro is frequently used. In my experience, micro was always used because I have more of a science engineering background versus a healthcare background, which I do not, but MC is used primarily in healthcare environments, and the micro, the Greek letter mu, is used in science and engineering settings, but means the same thing, 1 million parts. 1 meter broken down into 1 billion parts, 10 to the 9th, nanometers. Okay, so if I had this meter stick and I broke it into 1 billion equal parts, I would have 1 billion nanometers, prefix N meaning nano. And when we're talking on the micro and the nano scale, we're talking very, very small scale for these lengths. Micrometers, you're talking about thickness of paint or coating. Nano, you're talking about things that are infused with nanoparticles to have certain properties. For example, some athletic clothing is infused with silver nanoparticles to fight off bacteria from excessive workouts and sweating. You have silver fibers that are put into some of these athletic clothing pieces to prevent bacteria buildup from doing this. That's why usually those types of clothing cost a little bit more too, because you have silver nanoparticles woven throughout the fabric. So very, very small scale, okay? Also small, but not as small. This we can see with our eyes, okay? But you get down here, micro, nano, not really easy to see with our eyes. So that's for length. We have the same prefixes that we apply to volume and mass. In 1 liter, you have 10 deciliters. 1 liter, you have 100 centiliters. 1 liter, 1,000 milliliters. 1 liter, 1 million, or 10 to the 6 microliters. 1 liter, 10 to the 9th nanoliters. Mass. Okay, we know that 1 gram is small. I already mentioned that the mass of 1 gram is roughly about half of the mass, or a little less than half of the mass of a penny. Thinking about a penny and how light that is. 1 gram, you break that into 10 equal parts, 10 decigrams. 1 gram, 100 centigrams. 1 gram, 1,000 milligrams. Okay, like I said, that the medicinal dosages are usually in units of milligrams. 1 gram, 10 to the 6 micrograms. Okay, a lot of your medicinal dosages are in the milligram to microgram scale. And 1 gram, 10 to the 9th nanograms. Okay? I presented this in a way that you have it equal to the base unit, to 1 base unit. Textbook chart goes into negative exponents, which sometimes confuse students. So I presented it this way. Textbook has it this way. For instance, nanometers. 10 to the negative 9th meters equals 1 nanometer. Okay, reciprocal. 1 meter equals 10 to the 9th nanometers. Okay, so I have it presented to you with positive exponents, because I know in teaching this, the negative exponents throw people off with this. Most people, maybe not all. Maybe you learned it this way and you've mastered it that way, and that's fine. But I have it written as equalities for a reason, for when we go ahead to do conversions. Okay? So these are the small units that we are going to discuss in this course, and then we will have 2 large units that we discuss in this course. Let's look at 2 large units that we're going to see in chemistry. Large units are larger than the base unit. You take the base unit and you stack it to make a large unit. Kilo. 1 kilometer is equal to 1,000 meters. Okay, so if I had 1,000 of these meter sticks lined up, 1,000 meter sticks lined up, that would be 1 kilometer. It's not the other way around. It's not 1,000 kilometers equal 1 meter. When somebody does running and they run, a 5K race or whatever, okay, 5 kilometers. Okay, that's 5,000 of these. All right. So a kilo is a large unit. 1 kilo, 1,000 meters. A megameter is 1 million meters. If I had 1 million of these lined up, I'd have a megameter. Okay, those same prefixes apply to volume and mass units. 1 kiloliter is 1,000 liters. 1 megaliter, 10 to the 6 liters. So if you had something on a production level, it would be on this scale. Same thing with mass. 1 kilogram is 1,000 grams. 1 megagram is 1 million or 10 to the 6th grams. Now, we have a few prefixes that look similar. And maybe you have the tendency to sporadically capitalize or lowercase letters to make it look artsy. We don't have that in science. Capitals and lowercases can mean completely different things, so we need to be careful of that. Do not confuse milli, micro, and mega. Yes, they all begin with the letter M, but milli has a prefix of a lowercase m. Micro is the Greek letter mu or MC. Mega is a capital M. So when typing or writing, you need to be explicit with the prefix because they all mean different things in different amounts, and you need to be cautious of the way that it's printed or typed. So now what we're going to do is we are going to do some conversions with metric units. Now, I know some of you may be thinking, or maybe you will think eventually, you say, well, I learned a metric system, back in the day and whatever past experience you had, and I know you just move the decimal places, so many spaces to the right or so many places to the left, because it is a base 10 measurement system. Well, that works for the metric system. You're right, because it is a decimal-based system. But we're going to learn a technique called dimensional analysis that we can use to solve any type of conversion, whether it's metric US, whether it's stoichiometry later on down the line in this course. Dimensional analysis helps you to solve any kind of problem where you're converting from one unit to another. It's a very systematic way. It does not involve moving decimals. So we're going to take something that is simplistic, such as the metric system, and learn dimensional analysis so that we can use a simple system to solve problems, and then we can apply it to later on throughout the course when we do things that are more complex. So we're going to learn how to use dimensional analysis to convert one unit in the metric system to another. Okay? And then we will also do conversions with metric US units as well, because in reality, yes, we're here in the United States. We have measurements. We have people's mass in grams. We have lengths in inches. We have volumes in gallons. We need to be able to convert from a US unit to a metric unit for scientific purposes. So we're going to do multiple conversions now for the remainder of this video. Okay. Technique of dimensional analysis uses equalities as conversion factors. The given units will therefore cancel out to yield the desired unit. You have a measurement with a given unit. You set up your conversion factor that comes directly from the equality. The given units will cancel out. This is what we call a conversion factor. Comes from the equality that relates the two units. Okay? So the given units will cancel out. Just like if you had an algebra problem, A times B over A, and you had to simplify that, you would come out with B. Okay, so it's just the units cancel out just like algebraic variables would. Okay? Let's look at a problem. Let's say that we have a measurement of 54 centimeters that we want to convert into meters. Convert 54 centimeters to meters. Okay, so this is our first example here. I'm going to do multiple ones in this video lecture. 54 centimeters we want to convert into meters. The equality from the previous board that I had up, or two previous boards when I gave you all the equalities, 1 meter equals 100 centimeters. You're going to take that equality and set it up as a conversion factor. What goes on top is the unit that you want to convert into, meters. What goes on the bottom is that the unit you want to convert out of, centimeters. Well, 1 meter equals 100 centimeters. You always need to have the number that goes with the unit. 1 meter, 100 centimeters. Students will say, well, don't I put the bigger number on top or the bigger number on the bottom? No, 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 no. What goes on the bottom is the unit that you want to convert out of. What you keep with that unit is the number from the equality. 1 meter equals 100 centimeters. 1 meter equals 100 centimeters. Now you cancel out centimeters, and the math would be 54 times 1, which is 54, divided by 100. So 54 divided by 100 is 0.540 meters. Okay, our initial measurement had 3 significant figures. Our final answer, 3 significant figures. Now you may be saying in your head, I'm just going to move the decimal place. That only works for the metric system. So you want to get this technique of dimensional analysis down now because we're going to be using it throughout the course. Do not think that every math problem you can solve by moving decimal places. Okay? Let's do more examples. Okay? This is one example. Let's do some more. Let's convert 459 kilograms into grams. 459 kilograms is our given amount. Our given unit is kilograms. We want to convert into grams. From grams to kilograms. We look back at our reference chart. 1 kilogram is equal to 1,000 grams. Units of kilograms cancel out. The math is simply 459 times 1,000 to give you 459,000 grams. Okay. Let's do another one. Let's convert a unit in a volume unit. Let's convert 75 milliliters into liters. Okay? So 75 milliliters is our given unit. We want to convert it into unit of liters. So remember, you take the equality that relates the two units and set it up as a conversion factor with your desired unit on top, which is liters, and your given unit on the bottom, which is milliliters. 1 liter equals 1,000 milliliters. Okay, you need to have the correct number that goes with the unit. 1 liter equals 1,000 milliliters. It's not always 1,000 on the top or 1,000 on the bottom. It has to be set up so that the desired unit's on top and the given unit's on the bottom. And whatever goes with that equality, you need to have set up that way. Okay? Milliliters will cancel out. So now the math is 75 times 1, which is itself. 75 divided by 1,000 equals 0.075 liters. And I kept the other 0 there for significant figures. 3 significant figures in the initial measurement, 3 significant figures in the final answer. Just like here we have 3 significant figures as well. Okay, what we did in the previous video with significant figures, we cannot forget when we apply it to actual calculations. Right. Now these are relatively simple, converting with one conversion. Okay, it's not always this simple with one conversion. Most times it's more than one conversion in reality. Okay. Let's say that we have some U.S. customary system measurements that we need to convert into a proper metric unit. In your textbook, Table 2.7 has metric U.S. equalities that I'm going to reference in the next couple problems. I'm going to obtain equalities from this table for the next couple examples. Let's say you have somebody's height in inches and you want to convert that height into centimeters. Convert 68 inches to centimeters. If you have a direct equality, by all means use it. If you go to table 2.7 in your textbook, and you look under the length column, you will have this equality for inches to centimeters. Sometimes we don't, and we'll need to use multiple conversion factors, but right now let's start off simple. 1 inch equals 2.54 centimeters. So we have a given amount of 68 inches, and in 1 inch we have 2.54 centimeters, okay? So this conversion factor from table 2.7, okay? So then the math, you do 68 times 2.54, and you would get 172.72 centimeters. But rounding to proper significant figures, we have two significant figures. This would round to 170 centimeters with two significant figures. Okay, if we're following the rules of significant figures, and this measurement had only 2, so the converted measurement, 2. Okay? The equality comes from table 2.7 to convert inches to centimeters. But we may not always have a direct equality. We may need to set up two conversion factors. Let's look at one where we have to set up a metric US conversion factor and a metric conversion factor as well. And if any point in the video you need to pause and write down and make notes and look over, by all means do that. That's one of the advantages that you can do with, with technology. Let's do another problem. Let's convert 78.5 pounds to milligrams. Pounds to milligrams. Well, if you look at your chart in table 2.7, you have a conversion for pounds to kilograms, and you have a conversion for pounds to grams, but you don't have anything for pounds to milligrams. So table 2.7, we can convert 1 gram I'm sorry, 1 pound equals 453.6 grams. Okay, and then we can use a metric equality for grams to milligrams. 1 gram equals 1,000 milligrams. So those equalities we need to use as conversion factors. So our given amount is 78.5 pounds. First, I want to convert pounds to grams. So in 1 pound, I have 453.6 grams. Now, if I ended right there, I would be left with grams. But we're asked to convert to milligrams. So I need another conversion factor. In 1 gram, I have 1,000 milligrams. 2 conversion factors are needed. Units of grams cancel out. The math, 78.5 times 453.6 times 1,000. You get a very large number. You're going from 78.5 pounds to little teeny tiny milligrams. You have a huge number. Sometimes you have to put it into scientific notation. If you wrote out what the calculator shows, you would have the following number on your calculator display. Okay. 35,607,000 milligrams. This has three significant figures. This has much more. So we would need to round this to 3 significant figures, which means to this place here. Put it into scientific notation. 3.56 times 10. 1, 2, 3, 4, 5, 6, 7. 3.56 times 10 to the 7th milligrams. Scientific notation, significant figures. We use them throughout the entire course. So what we learned in the beginning of chapter 2 is going to follow throughout the course. Doing these conversions with dimensional analysis. We're doing it right now with metric units, with U.S. customary system units. We're going to use dimensional analysis all throughout chemistry. Okay. Let's do some more problems, okay? Let me give you some word problems. I would be doing you a disservice if I just said convert this to that, because life has word problems. So let's do some word problems and do some conversions that involve word problems. A gas tank has a capacity of 28.5 gallons. How many deciliters is this? Okay. Outside the United States, if you go to get gasoline in a car, it's usually in units of liters. It's metric units of liters. Okay, so you're paying per liter. United States, you're used to paying per gallon. So we will need to convert from this U.S. unit to a metric base unit. So we can go from gallons to liters, and then we can go from liters to deciliters. So 28.5 gallons, we want to convert into liters. Go back to table 2.7. Okay, and 1 liter, I'm sorry, 1 gallon has 3.785 liters. So 1 gallon. Okay, this is table 27. Okay. Now we want to convert liters into deciliters. 1 liter has 10 deciliters. So these are the metric equalities that I had written out on the board. Okay, and that are also in table 2.5. Okay. We do the math. $1,078.7 deciliters. Okay, but this has 3 significant figures. Right now that has 5. 1,080 deciliters, 3 sig figs. Significant figure, trap 0, significant figure, non-zero. 0 at the end of a number is not significant, but it's holding the magnitude of the number. Okay. Let's look at another example. Another word problem. Okay. An intramuscular medication is given at 5 milligrams per 1 kilogram of body weight. What is the dose for a 175-pound person? Okay. First of all, intramuscular medication, something like an EpiPen, where the drug is delivered through a muscle. For the EpiPen, it's delivered through the quadricep muscle and the thigh. Okay, so medication dosages are based upon the person's weight so that they are effective. 5 milligrams of this medication per 1 kilogram of body weight. Well, if the person weighed 1 kilogram, which is roughly 2.2 pounds, which is basically a premature infant, then 5 milligrams would be sufficient. But this person weighs 175 pounds, and we want to know the dosage that they need to be given of this medication. So what is the dose Forgive me, I forgot to write in milligrams. For 175-pound person. This is a very realistic problem. A lot of people take Chem 110 because they want to go into healthcare professions. And these kind of calculations are what you're presented with in that field. Okay, you could be going into science or engineering, and you could be doing problems with gasoline conversions or thicknesses of coatings, okay, or you could be doing medication conversions in the healthcare professions. It's all conversions, just different units and different applications, but the math is the same and the setup is the same. 175-pound person, we need to convert the pounds to kilograms. Okay, well then how are we going to go from kilograms to milligrams? Well, we're given a conversion right in this problem. 5 milligrams medication per 1 kilogram body weight. This is inequality right here in words. But you're going to have problems where you don't always have this equals this. You have to deduce that information from the word problem. Let the units be your friend and giving you the information in the problem. Being able to recognize information in the problem from the units. Don't let word problems intimidate you. You have units which will help you to solve it. So, 175 pounds. That's how much the person weighs. We need to convert their weight in pounds into kilograms. So 2.205 pounds is equal to 1 kilogram. Okay, again, this comes from table 2.7. Now I need to convert it into the milligrams for the dose. So 5 milligrams dose for 1 kilogram of the body weight. Okay, this comes from the word problem. Pounds cancel, kilograms cancel. I'm left with the milligrams of the dose. 175 times 5, divide by 2.205. Okay, the final answer comes out to 396.8 milligrams. If we round that to 3 significant figures, 397 milligrams. Okay. There are lots of problems recommended for these 3 sections which are combined. Okay? They all involve the same setup, but they may involve different conversion factors. I strongly encourage you to work on this and let me know if you have any questions so I can help you out if you're stuck. Okay?